Okay, so today is Go Math 8-4, and we're talking a little bit about expressions and equations. So the first thing that we want to talk about is how to tie in what we did the last couple days into our lesson today. So we started with expressions, and how do we take numbers and represent things that we don't understand yet. And we can still work with them, we can play around with them, and we can help describe them with an expression. Now, if that expression is equal to something, right? So we had like d plus 5. That's an expression. That expression is equal to something. We'll call that 7 equal. I now have an equality. So my equality that tells me here that d plus 5 equals 7, I would refer to that as an equation. So with my equation, when I want to solve it, we looked at possible solutions. So they say, well, is d equal to 3? Okay, well, 3 plus 5 is not 7. So no, d is not equal to 3. Is d equal to 2? Well, 2 plus 5 is 7. Yes, d is equal to 2. But how do I get to d if I don't already know what my solution may be? And we're using some pretty simple equations just to get us started here. So I don't want you to think that it's all as easy as this. They're all the exact same problem. We just may make them longer in the future, right? So what I'm going to talk about today is known as inverse operations. Inverse operations. All right, so inverse means the opposite. The operation, well, so instead of adding 5, do I subtract 5 from d? Well, that wouldn't make sense. But if I remember that this was a scale, and I have 7 over here, and I have d, whatever d is, and then I have 5, and I know that they have to be equal. Well, if I remove 5 from here, I'm going to take 5 off. I also have to take 5 off of here. Now, d is equal to 2. Oh, okay, so we're on to something now. We looked at algebra tiles, and we actually physically moved some things away. So inverse operation is essentially saying that instead of adding 5, I'd subtract 5. But whatever I do to one side, I have to do to the other. So just like on our scale here, I take 5 away from both. It's an inverse operation. What I'm left with on this side is d. I have an equals sign. And 7 minus 5 is 2. Now we go back and check our work. Is d equal to 2? Well, 2 plus 5 is 7. I've checked my work and I know I'm done. Okay, so the inverse operation. Doesn't really matter what the operation would be, such as 24 minus x equals 8. Right? I just picked an equation, and we're going to make this work. Whatever I have going on here, I would subtract. So 24 minus x, well, I can go ahead and, instead of subtracting x, let's add x. Oops, sorry. Add x to both sides. And I get 24 is equal to 8 plus x. All right, so now instead of adding 8, let's subtract 8 from both sides. I can pull them away because now I have an equation that I can work with. And I get 16 is equal to x. So come back up here. 24 minus 16 is 8. That does work. I'm going to put my plus x here so that's not as confusing, right? I'll try one more, and then I'll show you what this looks like in our book. Let's do x minus 7 equals 14. X minus 7 equals 14. Okay, so inverse operation. Instead of subtracting 7 from x, let's just add 7 to both sides. And I'm left on this side with x. Negative 7 plus positive 7, they cancel each other out. And 14 plus 7, I'm adding 7 to both sides, is 21. Go back and check your work. Is 21 minus 7 14? Yes, it is. Inverse operations. All right, so now let's look into our book here. While cooking dinner, Carla pours 5/8 cups of milk from a carton. This leaves 7/8 cups of milk in the carton. So we write and solve an equation to find how much milk was in the carton when she started. All right, so if I'm thinking this through, how would I write this as an equation? I'm thinking this through. I've got some milk. How much milk is in the carton? when I started? Well, I don't know what that is. All right. Then I pour out 5/8 of a cup. Well, is that adding or subtracting milk from the carton? Pouring it out, I'm subtracting 5/8. And what am I left with? This leaves 7/8. Ah, okay, now I have an equation. I can work with this equation. Instead of subtracting 5/8, I'm going to add that to get rid of it. And whatever I do to one side, I have to do to the other. So really this problem is x is equal to 7/8 plus 5/8. Well, I have a common denominator of 8. That gives me 12/8. And I can simplify 12/8. X equals 8 goes into 12 one time. I'm left over with 4/8. 1 and 4/8 simplifies to 1 and 1/2. And I would ask myself, well, if I had 4/8, 1 and 1/2, and then I subtract all of those 8s, right? 12/8 minus 5/8 equals 7/8. So I've checked my work. Showing everything right in here will save you time and make it easy to see any mistakes that you have. So again, inverse operations. I'm taking my equation and I'm doing the opposite to both sides of the equation to remove portions. The name of the game in algebraic expressions and equations really, is get the variable by itself. So whatever I can do to both sides that would get the variable by itself. Okay? So inverse operations, if they're asking me to add, I'm going to subtract. If they're asking me to subtract, I'm going to add. If they're asking me to multiply, I'm going to divide. If they're asking me to divide, I'm going to multiply. So let me give you one more example here before we leave. What if I had something like 12 over x equals 3? People get really, really weirded out by this. Say, oh, well, I'm not really sure. Just remember that every fraction is a division problem. So this is really 12 divided by what is 3? Well, instead of dividing by x, I can multiply by x. And I get 12 equal to 3 times x. Now let's divide by 3. Divide by 3. 12 divided by 3 is 4. Is 12 over 4 3? Yes, it is. Okay, so inverse operations. Take what they're asking you to do. If it's add, you're going to subtract. If it's subtracting, you're going to add. You do the opposite and clear the way for the variable.